Hello everyone. I hope you all doing well these days. I'm Alablela FXTD and we will talk about truck rigging today. But firstly, we need to talk about motor features and cone twist constraints and hard constraints and difference between angular motors and target motors. But before we start rigging this truck, we need to make some basic examples and how can we spin and rotate things with dopes and constraints. Okay, so let's start. Okay, so let's start with this basic scene. Let's consider this like opening gate and closing gate. Okay, for cars, and we need to lift this weight with a constraint with motors. Okay, we will talk about in this basic example about cone twist and target motors, and later we can discuss the spinning or angular motors of hard constraints. Okay, so to generate constraints we need this is a very basic scene. I have some boxes and rotated and aligned with this basic scene and give them name, descriptive name. Okay, I can unpack it here and transfer names with me, so I can have now name attribute on these points. Okay, and delete these faces and extract centroid for each face, and here I can connect now a line here to make a primitive or a spline, and I can connect or can give it some useful parameters or attributes that not useful. It's crucial for Bullet to recognize this constraint. What is the first one is constraint name. We can give it like twist motor like this, and this is the type of this constraint. I need to look the position and rotation with all like this. Okay, so now I need also to measure the wrist length. Okay, measure. I can use measure sub or easily for convert line. It's can compute length of primitive. Okay, so now I have 0.7 meters for this constraint. Okay, let's make the network, connect back pieces here and constraints here. I can make rigid body solver, back object, constraint network should be fourth input, and backed object will be first input. I also here made this rotating one as active and didn't put an attribute active here. So when I merge these, this will be active. It will grab one, and this will grab zero by default. Okay. Okay. So here I can first context. Okay, that's fine. And here I need to get cone twist constraints relationship and give it same name I have specified before. So I think I wrote twist motor. Yeah, this is correct. Here twist motor. Yeah, and this for this twist motor. I think I did something wrong. Constraint name and constraint type here. Sorry, this type. Yeah. So constraint is showing up like this. If I start playing, nothing happen as this is like balanced. Okay, but I need here to start specifying the axis, the rotation axis or freedom rotation to start rotating things. Okay, so let me yeah, this is the axis I need to rotate in this range. Okay, so if I play this now it's not, it's still, it's working, but the gravity is like it's balanced. Okay. uh okay, so what if I translate it like this amount, okay, and start playing? We can see that this blue line is the goal, is the up axis. Okay, it's not allowing this up axis to exit the angle I specified. Okay, so what if I made it 90 degrees like this? Yeah, it's not exiting the angle again, but I need to stop this and to be perpendicular to this static object. Okay, and also I don't need the gravity to affect or to force this object to fall. I need like pretending that here as a motor can rotate active object. Okay. Okay, so let me specify 90 degrees here and get back again this to 90 degrees to rest position. And here I can start making or enabling the motor feature here. If I here like start playing with these numbers, we can see the green line here is showing up. Here's the motor target color. Okay, so this like indication about the where we should lifting this, which target we need to lift this or rotate this. So I think the right axis is, yeah, this one. Yeah, this one is the right one. If I type here 90, we see that motor rotated this object with 90 degrees. Okay. Okay, we can animate this like this. So here we can have 0, and here we can have 90. We can also have 90 here, and we can have 0 here. So we can see it's like and open again if cars enters. Yeah, but we can see that it's not lifting up. Why this happens? Because sleeping parameters, sleeping feature happens in the DOB network. So when this resting like this, okay, it started to be asleep or deactivated. Okay, even I can increase this sleeping time for like 10 seconds. So any active object will not sleep after 10 seconds. So we can see here it should be working. Yeah, so it's working now. So this is basic idea of motors and angles. Okay. Okay, but what if I need to rotate the another direction? Okay, I think I can make it like this. Yeah, so I flipped the negative one, the goal axis here, goal up axis here. Okay, and the goal twist should be the constraint twist axis, and constraint up axis should be equal to the these two. Okay, so twist should be constraint twist, and up should be up. So this linked to this, and this linked to this. Okay, yeah, here. Also, the sorting here, the point number matters. So this is static one, and this dynamic one. Point one is the pivoting point. This point should I rotating around. Okay, this one I should rotating around this point. This is my pivot. So um, um, uh, order is matter. Okay, if I reverse it, or if I like pick this point here and start modifying the position. Okay, and see the simulation. See, it's like not pivoting right. It's not, this is not, it should be pivoting from this phase, but now it's like different uh, pivoting rotation. Okay, now let's talk about the angular motors. The previous one was targeting, so we was targeting the up rotation to specific angle. Okay, now we need spin objects around axis freely. Okay, so to achieve this spinning effect, we need to specifying um, hard constraints. Okay, I have also here some basic objects. This like collider. We are pretending here to make like a washing machine. Okay, and this some scattered some basic faces, basic shapes here, and make this to be concave. So I specified this object to be concave with this attribute. Okay, if other objects didn't specify an string here type, it should be as default. Okay, so let's make constraints, okay, and make dops. But firstly, I think I need this one, this object here, and this object here. Okay, and I need to make constraint between them. So I can here connect adjacent pieces with higher search radius to make this constraint. Okay, I also can specify the constraint name and constraint type. Hard motor, and this name, not name, should be type this time. Oh, as I need to lock position and rotation. Okay, I need this connect adjacent pieces, computing the rest length. Okay, now I can make lob network, connect this one to this one, RPD, not real body, back to object. This one should be first context geometry, and constraint network here, and grab the fourth one, and here I need hard constraint relationship and give it name as a specified hard motor here. Also I think I typed something wrong. Yeah, some typos here and still erroring. Constraint, yeah, this time is correct. We can see the constraint here. This one, this is constraint. If I start playing, just falling down. Okay, I need this object to spin like a washing machine. Here I can start playing with angular motor. If I enabled one axis, okay, around this should be rotating around x axis. Okay, this is x. Let me draw it. This is x axis, so I can rotating around this axis, so it should be rotating this way, yeah, this way and this way, this object. Okay, but as I have here colliders, so it will be, it can't be rotating this way. Let's see. Okay, it will not rotating as I didn't give it angles to rotate with velocity axis. This is not angle, this is velocity axis. So it's zero, so zero velocity around this axis. So I need to give it 10. For example, it should be rotating 10 degrees, or not 10 degrees, with velocity of 10 around x-axis. Okay, but I need to rotate around y-axis, so around this axis here. If I and this is weird thing, but if I make it 1, so I can rotate around y-axis, it just disappear. Why this? I'm not sure why. But if I give it like very tiny, small value like this, and give it like 10, it should be rotating. I'm not sure why, if it's like completely 0 and completely 1 erroring, but this how I can make it spin around y-axis. Okay, so yeah, this is very basic one. If I, and this figured out with some of playing, if I make 3 axes or 3 motors around 3 axes, x, y, and z, and type here 1, and type here 0, and type here like 10, it should be spinning also. I'm not very understanding this, how this working underneath, but yeah, this is like spinning objects. So we are building up some concepts to make truck rigging and spinning wheels and steering wheels. So this is also a basic idea to make wheels to rotating around x-axis, or not x-axis, yeah, it's rotating around, I think, yeah, this is hard constraints and rotating around the axis, but I didn't specify the axis here. Yeah, I think, yeah, I specified here. This is axis. I override the axis with vector attribute on constraint here. So this parameter should be controlled with subs, not dobs. Okay. So let's start downloading the assets I have used. This is free model. Okay, you can download. I also have done the setup before to save your time, also for my reference. So I will not build the modifying stuff or editing geometry or making splits and making or assigning name attribute. I will create constraint network and dot network. This is the core of the setup, or the core of the tutorial, to save your time. Okay, so here I will walk through the file. I just downloaded the file here, deleted some unwanted geometry, scale it down to Houdini units. It's like 20 meters width. Okay. Also, this node should orient if geometry you might download some offsetted geometry like this, and you need to orient and align at the center. You can make it manually, but I did some HDAs here to help me to just align the model, if even it's it's flipped or rotated in weird way. It just correct this orientation. Okay, it's very crucial to adjust or rotate your model to and at the specific axis, even z, even x, whatever, but it should be rotated correctly. Okay, it should be aligned to specific axis, no shifting at all. Here I just adjusting the minimum y, so it's sitting on the ground, converting name to path here. This for, I think I will not use this anymore. Okay, also I have moved the backward body, the weight a little bit, so to rotate this front of the car. Okay, so I can make this rotate in this way or rotate in this way without colliding with the body. Okay, here starting make this part of the truck, splitting wheels from body. Okay, make some names here. Also here I selected the front of it. Here I'm selecting the wheels, but I just noticed that wheels are connected with the axle, so I just removed it here, so I will not see or need the axle geometry, so I just kept the wheels only. Also this happens here. Okay, I merged all wheels together and assigning name wheel to it. Here the front, and this is the body. Okay, this is prepared asset. Okay, I start making some geometry modification here. So firstly I selected the body geometry, and if I highlight wheels, we can see there are some penetration. This will make some artifacts at the simulation, so we need to make it like free to move. So here I edit or just nudge these polygons a little to make collision free here. Made some poly extrude for specific edges, and diffuse geometry together, polyfill, and make unified mesh here with some dilate with lapse. This is lapse node with some dilate and project to original. I think it's not needed, but this important for convex decomposition, as this concave shapes will not work with bullet, but we need concave shape. So shapes like this, it's considered as this is concave shape. So a lot of concave shapes, and tiny and big, that will form the this will form our mesh. Okay, I made body or append attribute or append name attribute to the original name. So I originally I was have body name here, and I append the segment ID. So each convex decomposition or decompose geometry have a unique segment ID. I appended this segment ID to body. Okay, so I have unique name for each segment. If I make exploded view, so this is segments will form the shape. Okay, this is like 63,000 primitives. This is a lot, so I just poly reduced it for like 15,000. Okay, assembled it without creating name attribute as I did it here. This also for the front of the truck, and make some polyfill and remesh, and make proxy geometry for front with poly reducing. I don't need any details, so much details. At this stage, I just only this concavity to make wheel colliding and interact normally with the truck. Also making backed pieces without creating name attribute. For the wheels, I didn't have a unique name for each wheel, okay? So I need to make name attribute like wheel 1, wheel 2, wheel 3, wheel 4, wheel 5, wheel 6, wheel 7, etc. So I fused the geometry together. Okay, here polyfill remesh to grid, making unified geometry with some division size to make unified mesh like this. Okay, here connectivity and extruded each wheel along x-axis to intersect them together. So here if I make VDB from polygons and convert it back to polygons, here I can get one unified mesh for the wheels here. So these wheels are well rotating together. Okay, and I can now here make name attribute with this wheel 0, wheel 9, wheel 0 to wheel 9. Okay, and transfer this to original geometry. So if I can now visualize name attribute, so each wheel now have unique name. Okay, I don't either need this amount of polygons. Okay, it's too much. Here I reduced it quite few to make it low res, maybe lower. Lower is better for sake of speed. Okay, here I just selected points like this to make color attribute here. This color attribute will be helpful for me once the wheels are rotating, so I can see visually how amount of rotating happens. Okay, assemble it and without creating name attribute as I transferred it here. Okay, here I scaled it with tiny bit with this matrix with this amount. If I lowered, so I just lowered it a little. So if I highlight the front or the body, so I need even more space from each wheel to the body. Okay, here also, so I have here wheels and front pieces and body pieces. Okay, I looped over each wheel to create proxy geometry like this. It shares same pivot as original wheel. Okay, and gives them a name called hub. Okay, so each wheel have its own hub. It's in the this is like this geometry will not collide or interact with the scene. It's just for pivoting things together and make constraints. Okay, so I have here hub, I have suspension, same idea. I have steering just for front of the truck. These wheels will rotating even this or this to steer the car. Okay, the vehicle. Okay, I have done for geometry preparation. Let's make now the geometry, the constraint network. Okay, I will firstly blast any body name attribute here on points, and I can connect adjacent pieces to create network of glue constraints. So all of these all of these pieces will be glued together to make unified body mesh. But I don't need this sparse unconnected pieces, so I will yeah, increase the search radius, so I can't see any floating pieces anymore. Okay, I can give this name and type. Do I can make strength equal -1, so it will not be broken. It's very strong. Okay. For the front, I can make same process for front. Okay. 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 So let's work now on the wheels and steering and hub and stuff like this. So let me grab wheel. Okay, and grab the steering and grab the hub. Yeah. Okay, so here let me arrange. Yeah, so we have here a wheel and hub and steering. The concept here that I will connect the wheels with hub with twist constraints and make them twist around the twist axis. I will specify freely to make things twist, so wheel will twist and rotating. Okay. As well as I will connect wheel to hub with twist constraints. Okay, also I will connect a steering with wheel with twist constraints again, but this will be for steering, not twisting. Okay, and will connect steering to hub to grab the animation happens at the wheels and transferring this animation again to wheels. The transformations happens at the hub, and I will transfer the steering values or steering motors to wheels. Okay, so here I can merge wheels to hub and connect adjacent pieces. Here I can find how much 20 primitives for each wheel. I have 2 points for each primitive for 20 for 14 wheels, 10 wheels. Yeah, 5. Yeah. Okay, I can give them also type. It should be a twist, no strength here. Type should be all. Okay, so now I have some basic constraint network for rotating or spinning wheels. Okay, I need to create a DOB network and start building pieces on top of each other. Okay, let me make DOB network here. These are blue and this are the rest, twist, and let me connect packed pieces here. Okay. Rigid body, packed object, first context, and here I need constraint network. Here blue constraint, and let me type this as blue, and need cone twist. Let me merge this twist together and this called twist. Okay, let me grab the force input. Okay, I can't see the constraint. Yeah, I made a mistake here. These all should be primitives. Yeah, now I see red lines, so this means that I grabbed the constraints correctly. Okay, if I start playing the simulation, Yeah, something happens. Okay, something happens. I need these wheels to spin. Okay, so in terms of making stuff spin along axis, let me disable, or okay, I will make this out and up rotations are 0 and make start to twist along this axis. Which axis? The x-axis here. If we see the blue line, it's x-axis, and the blue line, yellow line, twist limit color. This is my limit, 180 degrees around the x-axis. Okay, the yellow one is x-axis. The orange one, I'm not sure why. The orange one is the up axis here. This is up axis along y. Okay, so now each wheel can rotate along or around x-axis. This is x-axis if we see the nomen here. Okay, what if I lowered the ground a little bit and rotated a little bit also? Yeah, something happened. Yeah, something happens here, but it's not perfect. Okay, I need here to disable collisions between the packed objects that shares one constraint. So disable collisions do that if I connecting the wheel with hub with twist constraints, I need to disable collision between the wheel and hub. Okay, this is what this parameter do. Okay. Also I can see steering wheels are detaching from the position. That's why, because I need to make another twist constraints called here steering, and these are connected together, the steering and the hub. Okay, same way. So I have two primitives in between the steering and hub. These are, it's same geometry, same shapes, but different name. This is very crucial. We have here hubs and we have here steering geometry. Okay, let me connect steering with twist, and here I need to make, let me here call this steering, this twist, and this steering, and connect steering here. Yeah, and here. Yeah, I will need to make angle or freedom range to steering around, so maybe 50 angles, but it's completely wrong axis. So I need to link the goal twist axis with constrained twist axis here, and goal up axis with constrained up axis. So these values will reflected here. I need to make it facing to z axis, not x axis. So here, yeah, like this, but it's parallel to wheel. I need to flip the up, this up. Okay, I need to facing to x, not instead of y. So like making this rotation. Okay, so here I can make like this. I just flipped the axis. Okay, if I start playing the simulation now, yeah, at least the wheel not the intermediary objects not detaching. Okay, but I still need to make twist constraints between wheel and wheel and hub. not hub, steering. So I need to merge wheel with steering, okay, and make twist constraints for these also to attach wheel in its place. If I look here at the simulation, yeah, the wheel, yeah, sorry, I didn't make constraints. Yeah, here it should be staying or linked to its position. It's not, it's still not linked. Okay, yeah, let's continue making the another constraints, and it will be completing each other. Okay, let's make suspension and guide constraints, slider constraints to help core be to be one part, okay, cohesive parts together. Okay, so yeah, here I need to connect wheels, not wheels, the hub here with suspension. Okay, so here wheels should be connected with suspension, but if I make connect adjacent pieces, yeah, this is looking fine. Yeah, so each wheel grabs the corresponding part. Okay, so I can make this like spring constraints, and I can merge it here also, and add this as soft constraint relationship, and we can call this spring to bring it here. And let's display simulation. Yeah, let's make it stiff. Yeah, we need connecting the suspension with body and front with glue constraint. So this will be same, it will inherit same orientation and transformation with body and front, and attaching wheels to this object, this objects here. Okay, so I think here I need to grab this, let me make some room here, and connect body to suspension once, and connect front and suspension once. So here I can make connect adjacent pieces, yeah, with one primitive, but I need only primitives that shares suspension and body. How can we solve this? Well, I think this primitive, let me show only selected, this primitive and this primitive shares same body syntax but different ID. Okay, the logic is we can run each primitive here and find each primitive has 2 points. I will compare the names for 2 points. If the 2 points have body or same element, if the 2 points have same element, this first part, it should be deleted. Okay, let's make this. It's pretty useful. Okay, so I will run for each primitive here. I will grab first point for each primitive. To make this, we have here function called prim points. It's return an array or list of points for a primitive. So it needs my geometry and my primnum for each primitive, and I can store this in integer array like this. So I have now for each primitive I have point ID, 2 points ID. Okay, to grab the first name, first part in name here. Yeah, I need to grab this first part for this. Okay, so what mean by grabbing the first part is I need just deleting any underscores and any slashes and any ID. So just return the string. This is string. Okay, this is valid for let's say if here I any suspension here. Yeah, this one. I think here I have some suspensions. Yeah, I will find it. Yeah, so this primitive shares, it might not be visible, but I have here I can draw like this is suspension geometry, and another lines is a body. Okay, so this one, this string here, this primitive here shares two different elements of names, suspension and body. Okay, I need to comparing. If these are equal, it should be deleted, and else it should be kept. Okay, so how can I grab first part? Let me clean the drawings. Yeah, I can make here string n1 equals point 0 name ts first point at the array here. Okay, this is my first name. If I assign this, if I assign this to primitive here, I can find body 237 and here 237. If I increased it to 1, it should be 233 here. 233. Yeah. So this is the logic. Okay. But still unique. I just need to remove any numbers, any underscores. I just need keep this body. This is string. So how can I filter this? I can make here split, and I can make here string of array of strings here. Split takes a string to split, and separator. What is my separator? Is underscore here. Now I can here filter the or first element if in the array is body, second element is 233. I just interesting in first part, so I can remove this brackets and here specify first element. So here now I have body. Okay, I don't need store this in string attribute. I just can make a variable, so string in n1 to be different from this one, and I can copy this line here. These two lines I can copy. This is should be in n2 for second point, and this for second point. Okay. To visualize this, it's not to be needed to visualize. I just filter or just comparing if n1 equals in n2. Okay, for first part in point 1 equal first part in point 2, just remove entire primitive. Remove prim 0 at prim num and kill the point attached to it. Okay, I see that we removed everything, but this because I think here, yeah, PTS 0 and PTS 1 are still erroring, and here in 2. Yeah, here I'm just interested with any constraint that its 2 points shares different parts, different names. Okay. This is procedural, and we can use it for different examples. We will see. Okay, let me duplicate this for connecting suspension for body. So this will be inheriting same transformation will happens to front or the body. It will be transferred to suspension, that the suspension will be connecting with hub that should be connecting to wheels. Okay, I can merge this here with other glue guys. I can specify also, as these are all always glue, so I can specify all of them here. Okay, strength -1. If I see now simulation, yeah, something, it should be nicer now. Okay, but the weight of truck is pretty high. Let's adjust this. Firstly, okay, let's make here different densities for parts I have. Okay, so here let's filter the, let's give all of them density by 1, so I can override the density attribute here, physical density by 1 here. So let's see what we can get. I think I need make ground more steeper. Yeah, it's rotating, but I see that weight evenly distributed. So let's make some changes here. I need some distribution for densities. Okay, so I can make here a group of points that should be weight more, but the base group is name equals front, so disclose the wheels here. Okay, so here would be if and group called weight. I need density to be 3. Okay, I think for this jump here, I think I will need some constraint iterations and some sub steps. Yeah. Okay, it's now, I think it should be much better, but I can see that wheels are swinging like this. I need to look any translation happens at this angle here, this axis or this axis. I don't need any translation happens at these two axes here or here. It just the translation should be happens along the constraint itself. Okay, so I will need guide constraints, the slider constraints. The constraints that can make only translations happens along the axis. Okay, specific axis, the specific range along axis. Okay, so in case to make such guide constraints, I can duplicate this here with name of guide. Guide will be, let me make this spring. Guide will be slider constraint relationship here. So slider makes object to translate along, let me here guide. Yeah, so the slider make translation happens along a specific range of motion along the axis. Okay, I can make here some different colors for better visualization. Okay, but obviously it's looking wrong, so I need to adjust the axis, so it should be along y axis. So I again relate copy this parameter here and this one here. So these are constrained together and make hinge axis to be along y here and go along x and start specifying the range that should wheels move into like this. And I don't any rotation. I need to lock rotation. I just need transformation. Okay. So I lower this rotation to 0. So it just will be translation along the axis. Okay. Let's see what will be happen. Let me display geometry again. Yeah. The wheel now stick at its position. I can make something helpful here if I make the rest length to 1.0.2 like this. It should be pushed a little downward. This should make something interact physically accurate instead of making this tiny gap. Okay, and lowering the stiffness a little bit, maybe increase the damping ratio to kill, maybe lowering this. Yeah, this should be much nicer. Yeah. Okay, now I can remove the yeah, here I can remove the position and rotation I did to the ground and start introducing motor to make this wheel to spin and push the car forward or backward. Okay, to make this motor constraints, I can, this is wheels. Yeah, I can merge wheels with up here, but just keep the, before merging, I think I can blast away other parts. So these wheels will be spinning or have motor feature merged with hub. Again, I can make this constraint here. So I have here wheel to hub. Okay, but this now should be motor and merge with other guys here and start making motor with hard constraint. I can type here motor. This motor I can here I can make it like blue, something scriptful, and make it, firstly I need to disable collision between motor and yeah, anyways it's disabled because of twist here. Any twist should disable collision between its objects. So now here angular motor I can make one axis along x and give it like 10. It's now spinning, and if I write here negative, so it's drag the, yeah. Okay, what else? I need steering to be introduced also. So here for steering I can enable motor here. So if I